Good morning. So today we are continuing on with our topic of taking the derivative of polynomials. We're going to be looking today specifically at the product rule, which is to say when you have one function times another function, how do you take its derivative? Now yesterday you did do one like this, this one here where you had a function times another function. What we did was we expanded it, and then we used our power rule and we were able to find its derivative. But of course expanding it is not going to be an option when you're looking at something like something like this, right? X squared minus 2x to the power of 10. Like, you're not going to be able to expand that. You're not going to be able to expand something like this either, right? Where this is just an insane amount of work if you're doing it that way. So what we want to do is we want to figure out a way that we can take the derivative of functions that are multiplied by other functions, using a pattern. And I do recommend that you have a read. I mean, not right now, obviously, but you have a read over 85 and 86 just to kind of ground yourself in the thinking behind this. But the product rule is nicely stated right here. Okay, so if a function is p times q, so you have two functions multiplying one another, then the derivative of that function is going to be the derivative of p times the regular function q plus the regular function p times the derivative of q. Okay, so it's kind of like you need to take the derivative of each section, and then you need to put these four pieces together in the correct order. Okay, and that's kind of the way I think you should try to think about it. So when we go to this first one, again, let's just define a few things. So we'll say our g function is 2x minus 1, and therefore our g prime is just 2, right? Because you can just use your power rule to easily get the derivative there. Your next function, h, let's say, is x cubed minus 3x, and the derivative h prime would be 3x squared minus 3, right? So whenever you're doing one of these questions, this is the way I think you should do it. Write down what the four puzzle pieces are. The four puzzle pieces are g, g prime, h, and h prime. And then you just put the puzzle pieces in the correct order. Now again, for today, there's only one puzzle. It's all product rule. But tomorrow it's quotient rule, and then later it's chain rule. So this is the way I think that will help you just kind of get through this as easily as possible. So f of x is equal to g of x, h of x, right? They're multiplying one another. Therefore, f prime of x is equal to g times h prime plus h times g prime. Now again, the order you put this in, it really doesn't matter. You can put, h g prime first. You can put g prime h. Like, try not to get mixed up on the order. It's one function times the derivative of the other function plus the other function times the derivative of the first function. Okay, so what we do here now is we just put the pieces together. Wherever I see gx, I write 2x minus 1. Then I have h prime, which is 3x squared minus 3. Then I put plus. hx is x cubed minus 3x, and g prime is 2. Okay, so you have that. Now, some questions you will have to take this and clean it up. Other times you won't. Like, just to go, for example, like this really complex one down here, do not simplify, because of course, like, when these get really complicated, simplifying them is not really making them simpler. It's really making them quite a bit longer. Something like this, I don't think this is too onerous to simplify, right? All you do is you have to FOIL out the first bracket and then expand out the second bracket. So the second bracket's a 2x cubed minus 6x. The first bracket, when we FOIL it out, would be 6x cubed. Then we have minus 6x. Then we have minus 3x squared, and then we have plus 3. right? So you're looking at, what happens here when you join these things together, and we have f prime is equal to 8x cubed. We have a negative 6x, another negative 6x, so we have minus 3x squared, squared minus 12x plus 3. Okay, and that should be the same derivative that we get, that everyone else gets. Now, GeoGebra is again really useful for this stuff because it has built-in commands to do this stuff. So we we derivative f, and you can see it comes up right away with the derivative 8x cubed minus 3x squared minus 12x plus 3. So, to check your work or whatever, really helpful to just use GeoGebra, use its built-in derivative command to make sure that you're taking the derivative properly when you're doing your work. Okay, so here the derivative of a function h, so this time h is the big function, f and g are the two components, is h prime is f prime g plus f g prime, okay, which is the same pattern as before, the derivative of one function times the original other function, and then the original of the first times the derivative of the second. So it says determine f and g for the given derivative. This, I think, is kind of an interesting thinking question. I mean, it's not that complicated, but you kind of need to know, what you're doing if you're going to answer it, because you have to look at this now and you have to think, okay, something on this side is the original function, and something on this side is a derivative. Something on this side is the other original function, and something else is the derivative. So, obviously one trick you can use here is the highest exponent on x must be a function. It can't be not a derivative, right? Because we know that when you take the derivative, the power on x goes down by 1. So like this 5x squared plus 7, for example, so, in our case, 5x squared plus 7 must be g of x. Again, you could call it f or g. It really doesn't make a difference, but I'm going to call it g. This means, right, then in the first half of the equation, I'm looking for a 10x squared, right, must be g prime, right, because, sorry, not 10x squared, I'm sorry, there's a mistake there, just 10x must be g prime, because, you take the derivative of this 5x squared, and that's the 10x. So then it follows that this 21 minus 3x must be the other function. So 21 minus 3x must be f, and negative 3 must be f prime. Okay, so that's kind of a way that you could work on this. Remember, like, I would look for the highest exponent, and of course that must be one of the original functions, and then from there it's just a chain reaction. You know what its derivative is, look for it. The other thing over here then must be an original function, and its derivative must be over there. Okay, so again, a nice question, not super difficult, but a good one to just make sure that we do in fact know what we're doing. So next we need to do the equation of a tangent. Of course, to get the equation of a tangent, we require two things. We need g prime of negative 1, which will tell us the slope of our tangent line. Then we need the point negative 1, g of negative 1, which will tell us the location of a point that or let's just call it the point of tangency. Just again, what I mean is simply the point where our tangent goes through. To do this, we need to plug in negative 1 into this equation to get the point, and then we need to plug in negative 1 into the derivative. So, it's up to you where you kind of want to start here, but let's start with the derivative. So g of x, let's say, is equal to f of x times h of x, let's say. Okay, so then I know then that f of x is 5x cubed plus 6x squared plus 3. And I know that h of x is x squared plus 3x. Okay, therefore f prime would be 15x squared plus 12x, right? Again, just using my power rule on the f function there. And the h prime, right, would be 2x plus 3, because that's what happens when you take the derivative of h. The derivative of g, right, so the derivative of the big function is equal to f prime h plus h prime f, right? So you just make sure you mix and match them, a different derivative with a different function in each part. So g prime in our case would be, put f prime first, so 15x squared plus 12x. Then I put h, x squared plus 3x. Then I add h prime, 2x plus 3. And then the original f, 5x cubed plus 6x squared plus 3. Okay, so that's g prime. Now, when I go to evaluate g prime of minus 1, I have to put in negative 1 into this bracket, so let's do that. I would get 15 minus 12 in the first bracket. In the second bracket, I would get 1 minus 3. In the third bracket, I would get negative 2 plus 3. And in the final bracket, I would get negative 5 plus 6 plus 3. So g prime of minus 1 would be equal to 3 times negative 2 plus 1 times 4. Okay, so g prime of minus 1 is equal to negative 6 plus 4. G prime minus 1 is equal to negative 2. So this is the slope of my tangent at the point that I'm interested in. Now again, just so we're not wasting too much time with me looking for mistakes or whatever, in case I made any, I'm just going to quickly get GeoGebra to tell us what the slope of that tangent actually is. So let's write 5x cubed plus 6x squared plus 3 times x squared plus 3x. Then let's take its derivative, and then let's do f prime of negative 1. It says negative 2, so pretty sure what we've got so far is right. Okay, now the other thing I need to know, so I have the slope, so this, again, if you want to just put a little equals m beside it, so I know, of course, the tangent I'm looking for is y equals mx plus b, and I know that that m is a negative 2. To find the b, I need to know a point, y and x. The point is equal to 1 and g, or negative 1 and g of negative 1. Let's just find out what is g of negative 1. Sub in negative 1 to the original equation. Okay, I get 5 times negative 1. Then I get 6 times positive 1, so plus 6 plus 3. In the second bracket, I get 1 take away 3. Okay, so g of negative 1 is equal to 4 times negative 2. And g of negative 1 is therefore equal to negative 8. Okay, so now I know that my the point I'm looking for is negative 1, negative 8. Again, let's take a quick second to check my function. Negative 1, f of negative 1. There's the point I'm looking for, negative 1 and negative 8. If we hide the derivative, you can just look at the original function there. And there you go. Okay, now the tangent, we know y equals mx plus b. Let's fill in what we know. Negative 8 equals negative 2 times negative 1 plus b. Negative 8 equals 2 plus b. Bring the 2 over to the other side. Negative 10 equals b. Therefore, the tangent is y equals negative 2x minus 10. Okay, when I take that tangent and I draw it here, y equals negative 2x minus 10, I know I'm right because if I zoom in on this point, I get that perfect tangent there. If I'm at all unsure that this is right, you can also write tangent. You can see what it's looking for a tangent, a point and a function. So the point is a, the function is f, and you can see the tangent it draws is the exact same tangent that I drew, right? So we know we're right here. Okay, I'm going to pause this one and we'll move on to part 2.